once you fly it. So that's full lateral. And full lateral is, if I use any other command while I have full lateral in, I will demonstrate the HPU pressure will fall down to into the yellow. So now I have basically a 10 horsepower vehicle, or I've, my shower head is like the ones on the boat, which is why and pinning the laterals at 100%, it's working the ROV really hard on the surface, so it's getting hot. And the water temperature is the same as the deck temperature, basically. So I might as well be doing this on the deck, and after about 2 minutes, it's smoking hot. And there is, but it's not working. So the biggest thing is the motor. So yeah, that was full lateral the whole time. So now I need full ahead to be the tagline on Hercules. So, and you see the current pushing me back over. So if I full lateral and full ahead, I'm dropping, just starting to drop pressure, but then as we go down, if I put the third function in, I don't have any jam. I can't do anything. So I can pick 2 of the 3, but I can't use all 3. Then we don't care. Yeah, it's between here and 50. And then the other thing I'm constantly thinking about, especially now we have a known issue in the bottle where it's browning out, we're losing telemetry or devices. Like the other day we lost control of the vehicle and I had to cycle high power to get it back. So if that happens, I don't have that lateral anymore. So if the boat was moving faster, I wouldn't have to worry about it. I could concentrate on troubleshooting or whatever. And that's setting yourself up for lights out launcher recovery. Those are the methods to my madness. So now I'm watching, as you probably heard me say before, just to keep Atalanta off the back of the boat. The lines are clear.
Control, back deck. That is Atalanta off the deck.
Hercules is dive, dive, dive.
Control copies. Hercules is dive, dive, dive.
Videos off comms for a sec.
What's that? Give you the stink eye. You can always refuse, and then I'll just say it, which some navigators do. Okay, on the way down, we're watching. Yeah, we're watching the comps there on Atalanta. So that gauge is at 6, which you can see now. You won't be able to see later. The gauge that comps are half on the line. The main res being the 100%, and one of the ones that'll get us is that.
Audio slate for dive Hotel 2101, UTC time is 220500.
The telltale, whether the system's getting too hot, is the motor. So you heard him call that on deck at 6. So it's now increased 2 psi just from the heat. And if you get too western with it, it'll wrap the gauge. If you're working these thrusters too hard on the surface. Okay, I'm gonna do something crazy. See if that manipulator will behave. Usually I would wait till 50 meters. I could regret this. For this manipulator with these big jaws, when it's stowed in, it's important to put the jaws parallel to the manipulator. See how far they open? If I open them like this, it will hit the nicely printed 3D linear actuator guard and probably knock it right off of there. And we hot it up so it has pressure in it and it doesn't flood.
So Dan, when you hit the big blue button, the manip went all the way closed, right?
Yeah, yeah, Ed. Yeah, crabbing is an option that Rennie, Nav Daddy and Nav Mommy like to do because they're Nav Daddy and Nav Mommy. But it has some inherent risks because the boat has a pointy end and it goes forward. That's what it likes to do. If you're going sideways, that works when it's calm. But if there's any kind of weather, and the other reason I don't like to do it is because I live in the bow thruster room and it wakes me up. It's very loud and annoying. And I don't, historically on here when we've done that, Johan, it's resulted in a loss of DP. And the other thing that happens is the mates confuse, like that happened the other night, they changed their heading instead of, because we didn't use the Nautilus track-a-line lingo, which was my bad. I have to relearn that on every expedition, apparently. I was testing the new mate to see if it would be lost in translation, and it was.
Control, back deck, that's all stop 50 meters, sending controls to the van.
Roger. So now
Control copies.
that's enabled. Now I give that thing a bump, and since we're all green lights, you can start heading down. Other way. There's a large amount of deadband on this for what seems like obvious reasons. The main gotcha is when you let go of it, you can ease back. Yes, you can hold position. Two tether ramps, that's crazy. Isn't that on your checklist to remind the idiot pilots to zero their tether ramps? That's an important one. Yeah. You want to hit run? You can hit run. I like to press buttons too. Okay, looks all good. I'm going to put Mackenzie here and leave you all unsupervised. You got this? You can get out anytime you want. But yeah. Ed, I'm gonna leave him unsupervised, but Johan's got this.
Copy, I'll keep an eye. What's our target depth, like 3,000? Check, 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 check. Almost. 71, 47. Okay. Coming out of auto iris. Here we go. I'm gonna go ahead and switch your salvo over to dive, unless you want to keep seeing topside cameras. No, let me wait till pilot's on comms. Hey pilot, I'm gonna switch your salvo over to dive, so you're not looking at topside anymore. I just switched your salvo from launch to dive. All right.
Mackenzie, as soon as you have the bandwidth, could you turn on the lower still camera? You don't have to do it right now.
I think that's part of the WCA, Mackenzie, probably in hotel.
Yep. Yeah, that's it.
That's a...
Before you get started with Brianna, I just wanted to confirm that WCA video streams are active.
I'm checking. Negative. It takes about 1 minute for them to come up.
Got it. Thank you.
Yeah. Keep an eye.
Yeah, I think we can turn those on. Hang on.
WCA cameras are on and active. Mackenzie, I could be changing the iris on your Hercules just a little bit. Audio test SPL 1, 2. It'll also show up on the sat feeds, show up on my recorders, show up on that device, show up there, show up here, and they show up here. SPL. SPL test 1, 2. I'm going to be adjusting the iris levels on Hercules for just a second. Zoom in on Hercules.
How about now? Good morning. It's the party line. How we doing?
Good morning.
Hi, Johan.
Hey.
How's it going up there in the front row?
Pretty good. New experiences, but in a fun way.
Mm.
How's it going back there?
Good, good. Getting excited about this dive.
Oh,
We
yeah.
are currently on descent. We are headed for about 3,300 meters. It's our target depth to start this dive. And we are at the Hoffaday vent fields in the Mariana Back Arc. And this is a site that was discovered in 2016. So we're back 9 years later to survey it. And this is a site that's host to some pretty amazing hydrothermal black smoker chimneys. So those are one of our main objectives on this dive, is to see those chimneys and hopefully get to see them in all their glory as they were 9 years ago. So the vents are arrayed in a west to east line of about 600 meters. So it's pretty flat around the surrounding area with some sheet flow lavas. And this is the first time that we have been back since the discovery in 2016. That was ROV Sebastian on Falcor. So that's our objective today. We're at about 1,100 meters right now. So on our descent.
How tall are the structures, Kyle?
How tall are those hydrothermal vents?
And do we have any 3D imagery of them from previous dives?
I think that's a great question. I would love to get Ed in on that. Maybe we can display some of that bathymetry up on the screen.
Anna might have a,
Or Anna, yeah.
or Johan might have a really cool 3D map they can share with us.
Yeah.
It helps me to get a bird's eye view of the neighborhood before we go in there. Otherwise, I'm like completely lost the whole time.
You wouldn't know it from watching.
Well, yeah, I have a pretty short leash, but in the big scheme of things.
Yeah, I know our team was mapping this morning, so we got some
You can actually
data.
put it up. One of the pilots can go hit screen 1 or Mon 1, which will be the red button. Top left on your video switcher, and that's now your destination. Then you can go to source PCs and scroll through the source PCs, and one of those should be, could be. If not, we can use the KVM to put it there. Mackenzie, what's your delta? Too late, you're dead. Don't get distracted too long on one thing. My mentor used to sneak into the control room and would come cover my eyes and ask me a random question. What was my heading? What was my depth? What was my altitude? And it didn't take me long to, as soon as I heard the control room door, I would look at my depth, altitude, and heading. Because he would then, if I failed to answer the question immediately, I would get punished. Usually a slap on the head or flick of the ear.
How many things are you keeping track of? I mean,
Everything.
how many, yeah. Your delta.
Delta, depth, wind speed, vessel position. I have a more tracking the trends, so I have a 3D map in my head and a 2D map. What are we looking at up there? I'll get.
Can we put that on the?
Hey Ed.
Yeah, I'm here.
Can you? Anna's going to talk about the event field in 3D. Can you put that up on one of the feeds?
Yeah, what computer is it on? MB Proc 2, right, standby. PC1, aye. Yep, that's up there, standby.
Right.
And cam nav's there. Let me just check one other thing real quick. Yep, ready.
Kyle can let our viewers
So,
know that.
Yeah,
Sat
this is
3
on
is there.
Satellite 3. If you're joining online, you want to see our 3D map, and we're going to let our nav team talk us through it a little bit, what we're going to be seeing today.
Hi, yeah, so this is a 1.5 meter grid, which is a very good resolution grid by Sentry, which is an AUV, multi-beam data from Sentry. So the contours that you can see here are 10 meters. So these are our vents. This is waypoint 2, so we're going to land at waypoint 1 and get a rock sample, and then we're going to travel over to waypoint 2, which is one of our smokers. So, which is about 20 meters tall.
20 meters?
Yeah. And then, yeah, we have this line, this nice line of waypoints that we're going to take a look at. I'm not sure what this waypoint 7.
That looks like
waypoint 7 is.
That looks like a caldera.
Voodoo crater, diffuse vents.
Voodoo crater.
Yeah.
That sounds scary.
So yeah, we have a lot of flat terrain in between these vents, and yeah, we'll check out if there's been any changes in the last 9 years.
What happens if you zoom in on, like, our first vent, for example?
If you zoom in on what, sorry?
On the first vent we're going to. Can you see more detail when you zoom in?
I think this is...
Oh, yeah.
Yeah, this is about it.
Has it really got a big pointy peak like that? Or is that exaggerated?
Well, we're at a 2 times exaggeration, but yeah, I would say that that's not as, in real life, it's probably not as pointy.
What does 2 times exaggeration mean?
Yeah, so here, so this is 1, so this is what it would actually look like.
All right.
And then we exaggerate like this to make things more exciting.
Why do you lie to us like that? Exaggerate.
Well, when we're editing, yeah, when we're editing, things stand out a lot more if we're exaggerated.
Right.
But it also looks cooler.
It does look cooler. So it's more, you do the 2 times thing so you can pick out the features you see?
Yeah. And so when I'm editing on other software, I usually do 3 times.
Oh,
this
yeah.
is 3.
That makes it look more like Disneyland.
Yeah, but so I think 2's a good compromise.
All right.
What's the black circle kind of around the rim?
Oh, that's a contour, this?
Yeah.
Yeah, that's a contour. So we have contour lines. They're lines of equal depth. And these are 10-meter contour lines. So this contour is 10 meters taller than this one. So it just gives you a really good idea. If the contours are really close together, that means it's a very steep slope. And if they're spread out like this, it means it's very flat. So yeah, so we can go over here, waypoint 11. This is mini crater, waypoint 11. So
We're going to go to that on this dive?
Yeah.
How tall is that?
So
can't count the contour lines.
We can do a 56, 60 meters tallish. Yeah. Yeah, so you can see here the contours are much closer together, so it's steeper.
That looks like fun. Hike up the mountain.
Yeah.
So, like my hike app, I can plan a path, and it will tell me how hard I'm going to have to pedal.
Yeah.
Through the path.
This is what the expedition leaders and the scientists do. They say, "Oh, I like that slope there." They make a little path with the waypoints. Put that in HiPAC for us so we can navigate.
And you use this software to make the
so they design the dives in this software because it's a really good for imaging. And then they'll convert it for HiPAC, which is 2D. So this is a really nice 3D imaging software.
And how about the mapping that was done this morning? Was there anything that came up, or did it allow us better resolution?
So we just transit mapped overnight, and this is, because this is a map from an AUV, which hovers like very close to the seafloor, so it can get really good resolution. So there's no way we could get as good resolution from 3,000 meters above.
Gotcha.
So
Why not?
we just use this existing map.
Well, why is it that AUV can get good resolution and we can't?
Well, because they're much closer to the seafloor. I'm not sure how close, but other AUV mapping dives that I've done, they've been hovering at like 30 meters or so.
Mm-hmm.
So then they get many more pings per area, because it doesn't spread. The pings don't spread out so much over the thousands of meters.
Mm-hmm.
So yeah, so they would have to do a lot more passes. Their lines would be closer together. And they would get many more pings per area,
How many,
which is better resolution.
like how many pings are in a multi-beam ping?
We
Hundreds
have,
or thousands?
yeah, hundreds. So
Hundreds.
when we have dual swath, I think it's about 800. Single swath is 400. So yeah, 400 pings per per ping. So I don't know if you've heard the sub bottom going.
In my sleep, in my waking
so
dreams.
it's been
If you
I
hear
don't know,
me,
between like 4 and 7 seconds. It depends on how deep it is, obviously, but that's about how often the multi-beam will ping, and then it's sending out hundreds of beams every few seconds.
if you hear me walking around going, it's kind of what our multi-beam sounds like, a bird chirping almost.
I had a question last night, Anna, from a student about the Mariana Trench, because when we were going over the trench the first time, we weren't able to get any pings. The data was not reliable.
Yeah.
And I'm curious, like, at what depth do you start to see that be unreliable?
Yeah, so our sonar is rated for 7,000 meters. And yeah, it was definitely around the 7,000 meter mark. It's called extinction. It's just too far for the sound waves to come back. So yeah, we didn't get anything past 7,000. And it was getting pretty unreliable around 6.5.
It was pretty fascinating to watch. I happened to be watching as we were going down the hill, and the returns from the multi-beam started getting, usually it draws this beautiful line as we're driving along, and then it started like holes in the data, I guess. Is that the right term?
Yeah, just weaker and weaker returns. Yeah. So there are other sonars which are rated for deeper, but our particular sonar, which is EM302, is rated for 7,000.
Is that a power thing, or is that just new technology and different kind of digital signals?
I'm not sure. Yeah, probably different signal processing.
I know our acoustic short baseline navigation system nowadays is some magical digital signal that changes and adapts as it talks, as the ultra-short baseline transducer on Nautilus talks to the beacon on Hercules. It adapts its frequencies to be able to hear better, basically. And the older ones, were like more of a set analog. They're like digital nowadays, from what I understand. My limited understanding of that technology, which is totally black magic to me.
So this point over here, we're not sure if it's like we're not sure if this is real or just a sound spike that showed up.
Are we gonna?
I don't think that's real. It looks too steep and sharp.
Are we going to investigate it, or is it
I
too
don't,
far away?
there's no waypoint on it, so. Yeah, our waypoints end here, if we have time.
How tall is that one again?
It's about 60 meters.
60
Yeah,
meters.
60 meters.
Wow. We might get to see that, Anna, because that'll be towards the end of the watch, eh?
Yeah. Oh, yeah.
A lot of the structures at Endeavour are in that height range, and some obviously down here that we've looked at.
I'm curious about the crater. Do you mind zooming in on that one?
Voodoo Crater.
Voodoo crater.
Voodoo crater.
Jacob, do you have any insight on how this crater might have formed, or why we see this in these hydrothermal vent fields?
Sure. Well, for one, it looks really small, so it's probably formed, as a little volcanic edifice, and we don't see a lot of those along the back arc, so I'm kind of stumped about why it's here, but, might have formed that had a semi-explosive eruption and then formed that crater, and, might just have diffuse venting from, like, either a deeper, shallow heat source. My guess is probably shallow, from just the rocks cooling, maybe. But it's been, 9 years since we've last been there, so I wouldn't be surprised if we don't see venting there anymore if it is the shallow source. If it's a deeper source, I'd expect to see some more, or like the same amount of diffuse venting.
What do you mean? What do you mean shallow versus deeper source?
So like a deeper source would be like a magma chamber, like, a kilometer or two, maybe more than that, beneath the seafloor surface. So like, and the shallow heat source would be like lava that was erupting and then is slowly cooling in the seawater and generating those diffuse flows from, like, 200 to 100 meters below the surface.
Mm-hmm.
So are you saying that last time we were here, if it was active from a shallower source, that was relatively recent eruption, or how long does like that lava still retain some heat if it's stored kind of shallow?
Like I'm not completely sure if that's even was like an eruption that occurred, or if it was just kind of like a cone that formed that collapsed, or
I see.
yeah, it was just me kind of guessing, but
Yeah, no worries.
the lava would cool. So rocks cool differentially. They're not great conductors of heat. So what ends up happening is that the outside of the rock can be cool and the inside can still be warm. And so you can still have that, like, and, that creates a lot of stress in the rock, so it cracks and it forms these kind of permeable pathways for water to flow through and kind of sap heap up from deeper in the rock. And yeah.
So that cooling, on Johan's question, is that something that happens over hours or days or weeks, or, geologists say something that's young is, millions of years old? What is that?
Yeah, I'm thinking in like the last, like, for young, probably within the last like 50 years. Like, I don't know.
Yeah.
We just gonna have to go and see, and
Uh-huh.
and I would probably have to read about it more and figure out what people were saying about it instead of just guessing. But
so I know we visit the hydrothermal vents every year off the Pacific Northwest at the Endeavour Field and the Axial volcano, and sometimes the trending is the same for years and years, and then sometimes there's radical changes between the time we've been there and the following year, depending on what's happening.
oh, yeah, Karina's here.
Decades, that's weird to think of the scale of something cooling on decades.
Yeah. No, it's very strange. And it can even happen faster than that. Like, you know, there's an eruption on, what is it? Yeah, Nautilus seamount in American Samoa, and that eruption occurred over kind of a 15-year period. And, you know, diffuse venting pretty much stopped after the first, 5 years after the fact. It's just like, it's just weird and, complicated. It's like when we were at Ahi Seamount, like it was still very, active venting going on, and so there's clearly still a heat source, but, it's just going to change from place to place. Yeah.
Okay, come out of that graphic and get back to our multi-viewer for on the descent.
Copy.
That's great content though, thanks guys.
Jacob, you were mentioning kilometers to magma chambers. Does that mean the seawater is seeping down kilometers below the seabed and then getting heated and coming back up kilometers?
In some cases, yeah, but I think what really kind of a magma chamber does to like a hydrothermal system is that it creates this gradient of heat from the magma chamber. So for example, let's assume like we have like basaltic magma, so that's going to be like 1,100 degrees Celsius or somewhere around there. And so you'll get this kind of radiating heat from it and the surrounding rock. And so the hydrothermal, the fluid or the water doesn't have to go down all the way.
Mm-hmm.
It can just go down enough into that gradient to get heated up and then come back out.
Yeah, and that's one of the reasons that like different vents have different physiochemical properties as well, is how deep they've gone, their circulation, and that kind of dictates some of the chemical processes that have occurred, and also the rocks that are available for them to interact with. And that's one of the reasons that fluid sampling at individual vents across a field can be so interesting, because it can kind of tell you like the wide range of different forms and different depths of circulation that's occurring in a hydrothermal system.
What does physiochemical mean?
Physical and chemical properties of a fluid. So I'm going to rely on Jacob to talk about the chemicals of hydrothermal fluid, but yeah, if you want to
Okay.
take that one away.
Yeah.
You could give us the like greatest hits too between the white smoker and the black smoker, since we've had some white smokers.
Oh,
But
yeah.
this is our first for this expedition.
Why
of a
are
black
some
smoker.
white and some black? Is that physiochemical differences?
I think that's, yeah, I think that'd be like physiochemical, but more chemical. So in the black smokers, you have more reduced sulfur or sulfides, which can form minerals like pyrite, galena, and other, minerals that have like a black color to them. So they kind of tint the hydrothermal plume black,
And the ROV.
with the white smokers, you have a higher concentration of calcium, like aluminum, and sulfate, which form minerals that are like whiter and tint the hydrothermal plume like white.
So boat still moving to the waypoint, or is it on holiday? Oh, it's still moving to the
Yeah,
waypoint.
we're still moving.
You can take off your forward way, Mackenzie, because the boat's moving. So see how far Atlanta is from where the boat is, because the boat's moving west and you're pulling it east. So, and if you're going too fast for Johan now, you can, what's that? Yeah. 400 meters to go. And that's going to take, what, half an hour? And we are half an hour from the bottom. Yeah. 37 minutes. Yeah, you can bump it to half a knot so we get there. Sure. It's easy to bump. It's easy to bump that illegal stick. Oh, that one. Well, what's the zero between waypoints, Johan? It's all good. Nobody was killed. Famous saying by one of our former Hercules pilots, who was a great mentor for me, by the way, when Greg Diffendale, when I first came on the system.
Diffendale, he still owes me money.
Yeah, me too, now that I think about it.
I'm just kidding. Yeah, sure, I'll be right there.
We're going to give you a bird's eye view of all the planned dive route from 1,000 meters, Verena. You look at the silver lining there. It's nice to be streaming while you're descending because you don't have to use any forward. You can dedicate all your beams to getting down to the seabed as fast as possible. Because the suspense is just killing me. But the danger there, as K2 and I can tell you repeatedly, if you're descending while the boat's moving, because you've added a zero where you shouldn't, which we occasionally do, and then you have this excessive layback like we have now, so 2 ship lengths basically, 100 and some meters. You stop the boat at the waypoint, and then Atlanta swings in, and you're concentrating on other things, and all of a sudden this giant 60-meter tall structure appears, and there's nothing you can do about it except come up, move the boat again, because you didn't stop in time, and then go back down, which can take, an hour, thus adding to the suspense.
You might have mentioned it before, Dan, but there's some hydrothermal vent sites have been so well studied that we have very good photo mosaics that show that site, and we use those as we superimpose our navigation on top of that, so we know exactly where all those smokers are, even if we can't see them at the moment, which is super helpful for managing our tether and making sure we don't burn it. Would be bad.
Melted a few components on
a
few ROVs.
We had a light on the top of Herc that had been in a hydrothermal vent for a long time. It still worked, but it was completely white instead of black.
One of the, I have several memorable ones from several vent fields. Down here, somewhere in the Tonga Trench, we were doing a survey with Ropos, and we welded the front of the bio boxes shut, and I didn't know it at the time. And I come on.
That's really
walk out
funny.
onto the deck, and Keith Tamberi has a wedge and a sledgehammer, and he's
Yeah,
beating on the boxes.
and this
to
is a
unweld
big
them
guy.
so the scientists could get their samples
Yeah.
out.
Oops.
I didn't realize you were on that cruise. I couldn't go. I had to stay home and teach.
I found the images from an expedition we had been on together, Marina, in like 2014, and I have to look at the metadata and find the name of that inlet on Vancouver Island. That was so beautiful.
It was Effingham.
It was Effingham?
Yeah.
Oh my gosh, it was gorgeous.
Yeah.
Just these, you know, majestic trees and a fjord-like setting coming all the way down to the water on both sides, and in a kind of misty fog in the Pacific Northwest. It was just gorgeous.
Yeah, it was.
What's Sally, the sponge lady, doing?
Sally Lease?
Yeah, Sally Lease.
Yeah.
Sorry, that's an ROV term for her. Sally Lease.
Yeah. No, she's still working on. Oh, they just published a really neat paper, observations from Folger, the Folger Pinnacle on ONC.
Yeah.
And they'd had these. Man, I remember working on the funding for this 3D camera system, still cameras. This is back in 2014 or so, or no, earlier, 2008, trying to deploy these still cameras and all of the imagery coming back online. And they were finally able to use, enough of the cameras worked that they could do a 3D imagery of a little sponge.
Oh, cool.
Over time, over a year and a half, watching it expand and grow, and then when the primary production, the big production in the spring happened, the sponge suddenly just swelled up, just became bigger and bigger, and then in the wintertime it shriveled down, got half eaten by a sea star, regrew, and it was just this life of a little small sponge that was probably the size of a baseball that they were able to image in 3D, and that kind of went viral on the internet about 6 months ago. It's really cool stuff, actually. But yeah, she's still working on her glass sponges. It's been really, really interesting work that's caught a lot of attention, and some of the results of her work is we were doing. She was doing up in the Queen Charlotte Sound area, resulted in the declaration of a marine protected area there on the sponge reefs, because the trawling was really, really damaging them.
Some very interesting dives with her and Robos, and a bag of fluorescein and sips.
Yep.
Very challenging conditions. High currents, cliffs.
Yep.
Shallow water.
Yep. I bought all those sips. I think they're still in the lab.
Are they?
Yeah.
We were talking about those a while back. Someone was trying to figure out how they could do something. I said, "Oh, what you need is a sip." They looked at me like, "Huh?"
When we work on cabled ocean observatories, there's several cameras usually deployed permanently on the seafloor, and they can get biofouling on the lens. And so we take a specialized instrument down to clean that biofouling from the lens, which is the T-BOS that we take down, which stands TBOS, which is the toilet brush of science that we use to clean the biofouling. It's very effective. They work great.
Right. Have you done the one in Saanich Inlet?
Oh my gosh. The Saanich Inlet is between Vancouver and...
No, this is on Vancouver Island. It's just off the Institute of Ocean Science.
Yeah, so it's off Patricia Bay.
Yeah.
And the currents through there, I think the nominal, like normal day current is, 16-foot current, or tidal cycle, sorry. So the current and the sediment is, it's very difficult to work there. There's a site in Venus that's,
the red book.
I think it's that yellow buoy right off of the Pat Bay. I mean, it's like,
That's Saanich Inlet.
yeah, that's.
But it's very quiet. I think you're referring to the one off the Fraser River.
Oh, that, yeah,
Off
where the
Vancouver.
Frechette is, yeah.
Yeah, and that's definitely an issue. The current tidal exchange is definitely problematic.
Pacific Northwest is having a record low tide right now, I think.
Oh yes, that's fun. Intertidal
Yeah.
stuff is really neat.
As a scuba diver, it's kind of funny because you can go and walk many of the dive sites that you dive, where normally they're, 25 feet of seawater, and you just kind of stroll around and look at things for 6 hours.
Oh, that's your cable, is it? You've already made a note, I see.
What might cause a tidal system to shift so much like that?
It's a cyclical sun-moon relationships that go through kind of almost epic cycles of the position of the Earth and the Sun and the Moon, and it's not a monthly thing. It's not even a yearly thing, but you get these interactions of gravitational forces that sometimes only happen, say, every 17 years. It's kind of like the cicadas that all came together in 200 and how many years, right?
Right, they all align.
Everything aligns, and suddenly you just get these massive tides. The boats in the marina are beached.
And the further north you go, the worse it is. So, Cook Inlet, Turnagain Arm up by Anchorage, Alaska, can have the tide come in these very large waves, which I think are called bore tides, B-O-A-R?
B-O-R-E.
B-O-R-E?
Yeah.
Thank you.
Tidal bore, yeah. They have that a lot around Bay of Fundy with the huge tides. Sometimes it's hard to outrun them.
For you or the sea life?
For me, working on the tidal flats. That's where I started my marine career, running away from the
tides coming in.
Yes.
Gotta go.
It's actually very dangerous.
Yes.
What kind of work were you doing there?
I was working on the animals living in the mud. I've been able to go deeper and deeper throughout my life. I started intertidal.
Right.
Went to coral reefs, went a little bit deeper to Saanich Inlet, and here we are. We're going to 3,600 today.
Ed, we had a question in the chat about those TBOSs.
Yeah.
If it was planned or if it was just something happened upon.
Man, they've been used for so long. I kind of need Dan's input on this, but my recollection is they were first used on the Canadian Cabled Ocean Observatory, probably on Venus. But there were a variety of things tried before we settled on a T-boss. Trying to fabricate something and trying to use things an ROV would normally have, and finally a fortuitous trip to a commodity hardware store resulted in the first deployment of a T-boss
or just might have been a little desperation on the ship.
Yeah, yeah, we,
Seems like maybe that follows a trend.
oh yeah, there's no shortage of walking around looking for something. What could I use to, because out here, you know, we can't have a package delivered. We can't stop by a buoy and pick something up. So we either have to fabricate it, and we have complete fabrication ability here with a wide variety of materials, including 3D printing, or we repurpose something, which happens a lot.
When we first went out in 1983, we discovered the hydrothermal vent system on axial seamount, and we had a thermistor with us. We stuck it in the vent, and it just melted.
Yeah.
And so the chief engineer on the ship took out a thermistor out of the that was used to monitor temperatures in the engines in the ship, and somehow the pilots were able to connect that, took it down, shoved it in the vent, got some temperatures, and then later on we were able to calibrate those measurements against a proper high temperature probe in the lab, and we were able to publish those data. And
wow.
You know, this guy was just, I was so so grateful that he was interested enough to, yeah, I can solve this problem.
Oh, that's
Ingenuity.
That's very cool, yeah. I know on our ONC cruise last year to the Neptune Observatory, we recovered one of the BARS systems, which was it's like a high temperature, long-term monitoring piece of equipment. And we were having trouble with our Hercules temperature probe. So we kind of had one of the engineers Frankenstein it onto our ROV and used it as our temperature probe for the rest of the cruise, or at least for a few dives. And Dan could probably speak more on that, but I think it was quite successful.
Don't give Chadwick any ideas if he's listening.
Right.
Or Verena.
Well, there's nothing to pick up here to do that.
I've actually thought about that. I have a temperature probe in our power distribution unit. I was thinking about robbing it, seeing if it would work in our wounded temperature probe. That was pretty clever. Who came up with that? One of the ONC engineers, I think.
I think that was Jeb.
I was just going to say, I would bet my money on Jeb. Yeah, that's totally Jeb.
That was Jeb, now
Yeah.
that I think about it.
Are there 3D printed tools that you've seen being used, kind of, you know, fashioned in need of a solution? The only one that I've seen on the ship was for a coffee, which, I mean, this was important to me, but it was for the AeroPress, so it could hang upside down in the workshop there.
Ah.
That was pretty sweet.
You're talking about our Fletcher?
Yeah.
Mm-hmm.
Yeah, the Fletcher was I didn't hear you at the beginning there, but I just heard AeroPress and upside down ROV shop. You know the origins of that?
No.
What's that?
No.
For ONC, we do a lot of electrical flying leads, or electric flying leads. So they're these 50, 75 meter long, basically garden hoses full of wires and oil, and they have a $20,000 connector on each end, and that can be fiber optic and or power and wires for telemetry, like a serial device. And they have Well, actually, I think the connector's more than that. Just the cap is, you could buy a nice new car for what the cap is. And getting the latching mechanism they have, so they're wet mateable. You plug them into the instruments on the seafloor. So we have to plug them and unplug them quite often, and they're hard to get off. And you need 2 hands to pull them apart. So some clever technician or engineer came up with a device they call a Fletcher. So they have a plate on the connector, and we mount the Fletcher on the front porch of the ROV, and we slide that in, and that holds the plug or the cap. And then the other end has a handle that you hold onto with the manipulator, and you basically unplug it from the cap and then plug it into the instrument. And so yeah, the Fletcher holds the flying lead. And some of the copy connoisseurs with the AeroPress like to do the inverted AeroPress on a rolling boat. That can have some undesired consequences, like coffee all over the shop and wounded coffee maker because it's very hot. So they came up with the Fletcher to hold the AeroPress, and then they got clever and put some magnets in it so it sticks to the ceiling. So that was a collaboration with our data engineer, Justin Lowe, and one of our Hercules pilots who both prefer the inverted AeroPress method. So Justin designed that in a program called SCAD, which is basically a CAD program, but it's all command line interface. So if you're a math junkie, like our data engineers, they basically, that was drawn in a command line environment where they're figuring out all the math and entering values into an equation to make an object.
Have you ever tried your hand at SCAD?
Yeah, but not anything from scratch. More so, in the maker world, 3D printing, there's a lot of, especially earlier on, there was a lot of people, a lot of geeks who like SCAD. So a lot of the models that you could download where you get the SCAD, it's just a file, right? And it's a very small text file, so it's really easy to download.
Right.
And then you plug that in to your local program, and it's very easy to modify. So you just change some parameters, and, make the base bigger or taller, or so they're easier to modify than downloading like a step file, which can be quite large.
Totally.
It's every time I play with it, it's a bit of a rabbit hole learning curve.
Mm-hmm.
But for people who use it all the time, they're actually quite fast at it. It's a powerful tool if you're familiar with it. Have you used it?
No, I've never tried SCAD. But I could see how it could be, once you get over the learning curve, rather quick.
Yeah, it's
maybe hard to visualize what you're doing sometimes, but
it's very useful for parametric things that where you're changing the parameters of it.
Yeah.
So if you have, if you've designed a cap for a jar, for example, and you have a jar with a bigger diameter opening, you can just adjust a few parameters, and you don't have to redraw the whole cap.
Right. Yeah. That's achievable, at least in SolidWorks as well. You can kind of link dimensions in a special way, but it's takes a lot more work than what you give a normal drawing.
It's really easy in Fusion parameters that are, if you take the time to set that up with your sketch at the beginning.
Yeah.
There's a kind of a discipline, if you will. And it's worth it if you.
Totally.
I have a bunch of parametric drawings that, spend a bit of time up front, and then instead of redrawing something from scratch, I just go change a few numbers. One of the ones is 3D organizer boxes that were printing for the ROV shop. That's all a parametric drawing, so you just tell it the size of the drawer and how many boxes you want in there, and it will auto-magically, and then how much gap you want between the boxes so they don't fit too tight, so you can get them in and out.
And you were printing 3 of those at a time?
Yeah. And the same character who was designing the Fletcher in SCAD, I was printing those boxes, and you can print 4 at a time. And took quite a while to print, and we have a lot of drawers to fill up. So before I knocked off for the evening, I would start a print of 4, and then I'd get up, and there would only be 3 boxes there, and I could not figure out what was going on. And I thought, the printer was messing up, or I was tired and I didn't start the print correctly. This went on for quite a while, and then these boxes started appearing around the ROV shop in odd places, and I thought to myself, that's a strange place for a box. Who keeps taking boxes out of the drawer? I'm trying to fill it up. I didn't make the connection. But our clever data engineer was an early bird, and he would go in and remove one of the boxes off the print bed.
You were going crazy trying to figure out what happened, why it didn't print that one.
My OCD would not give up. Quite dense in some cases.
It was a good
I
gag.
don't
get it. And wasn't it the time lapse that finally?
Yeah, the printer has a time-lapse function. So I had double-checked all my settings and double-checked my drawing, and I thought maybe when I exported it, I didn't, or the printer has a multiply function where you can tell it, how many multiples of a model you want to print. And so I turned on the time-lapse, and then I was reviewing the time-lapse the next day, and I'm like, oh, it's printing 4 boxes. But then I went and looked, and there was only 3, and I'm like, what? And towards the end of the time-lapse, there's this very recognizable hairy hand that comes in and lifts one of the boxes out. And I've seen those hands at work on mice and keyboards for a while, so I immediately recognized it.
He was so proud of himself.
The fact that I didn't get it and the boxes were appearing, I was like, duh.
Wasn't there one on the ceiling?
Yes, there was one on the ceiling. There was one right next to the coffee where I come in the morning with one eye open. So obviously wasn't going to get that one. I should have got a clue because we were running out of filament colors. So
yeah,
but I was trying to fill the drawer up, right, so I could start putting parts in it.
Yeah.
Getting beams?
Speeding up.
Oh.
No beams yet.
No beams. Getting close.
Yes, I will need you to remind me of that many, many times.
Roger. See if she'll get it. She should know that because it's in giant purple numbers in front of both of them. Huh? You paying attention up there? What's changed? What's changed? No. The speed, yeah. That giant thing that we're sitting on that's dragging you around on the seabed at close to 3,000 meters. But that will affect, so you have no forward on, remember, so it's not going to affect you yet, but it's a thing to start keeping an eye on. So it will continue to drag you. Well, Atalanta is 3 ship lengths. We call that our layback. So because Nautilus was moving at half a knot and we're 3,000 meters below it, 3 kilometers. And it's a pendulum, so it takes, like when we're shallow, it's less of a pendulum. It doesn't swing so far out. And it's probably going to take us another, I don't know, what do you figure, Anna? 10 minutes? 15 minutes to swing in?
When we were...
Yeah, whenever they're ready there. Just down to point 2 so he can hold position.
When ROVs work as deep as 6 kilometers, there's a ginormous delay from when the vessel starts moving to when the camera sled or clump weight sees that movement. And so it's very difficult to do precise work at extreme depths because of that lag.
Yeah, we don't want to make Anna nervous, but it can be very challenging when you're trying to dangle a 4,000-pound sled 3 kilometers below and nudge up next to a 20 to 60 meter tall structure, so we can get close enough to image it with Hercules. Patience is the key. It's not one of my virtues.
So we're approaching about 3,000 meters, and our target is around 3,300 meters for this dive. Verena, we talked a little bit about the hydrothermal vents and some of the geologic features. I'm wondering if you want to give us a little introduction about some of the biology we might see.
You want to trade out?
And especially, I know we've been thinking about the differences between those white smoker and these black smoker hydrothermal vents, and what maybe different life they support in those environments.
Okay, after our dive at Burke Vent Field the other day, which turned out to be dead, I don't want to raise expectations. I'm just hoping we still have an active vent field here that is just as vigorous as we saw it. Would be 9 years ago now. So I won't go into a ton of detail. It'd be more interesting to talk about it when we get there, and see what's there. So we've got a number of sulfide complexes, and as Jacob was commenting, the differences between the arc and the back arc, for the most part, there's a couple of exceptions, is that the hydrothermal fluid has a lot of hydrogen sulfide here. The white smoke that we see coming out of many of the arc vents is particulate sulfur, so native sulfur, and that precipitates out a white color, or slightly yellowish sometimes. Down here, however, what's happening is the seawater, cold seawater, is sinking through the cracks in the basalt crust. Deep down underneath, it's it's getting heated up by a deep heat source, and then expanding. It wants to go up. It's lighter than the fluid around it, so that's what's coming up, superheated. And as it comes up, all the oxygen disappears. It's dissolving sulfur and the sulfate in the water turns to sulfide, and it's dissolving metals out of the rocks. So the particulates in a black smoker then are, as Jacob commented, the hot water is inside the chimney, but as soon as it hits the very cold seawater, where less than 2 degrees centigrade, instantly precipitates into what we're calling smoke, which is sulfide particles. But on the way up, it's also building these chimneys, doing the same thing, precipitating the sulfide minerals that are slowly building these chimneys structures. Meanwhile, depending on how dense that rock and formation is, there could be fluid only coming out at the top because the rock is incredibly dense and fluid can't get through the walls, or the wall or the matrix of the rock is really quite relatively loose and there's a lot of hot and warm water diffusing through the walls of the chimney. And that will dictate whether or not there are animals going up the sides of the chimneys, or are they only concentrated on near where the smokers are coming out. So it's kind of a mosaic that one sees of just looking at rock sulfides and then areas where there's bacterial mat because there's only a trickle of fluid coming through the sides, and then areas where there are a concentration of animals. And at this site, that was the dominant animals were shrimp, they were hairy snails, crabs, and some limpets were quite common as well, and some other smaller snails, as well as the fairly ubiquitous around the base, the anemones and squat lobsters as well. So we'll just see what we see. And I am just very anxious to, it was one of the more spectacular places that I had seen, but we just never know what time and the Earth has done.
Certainly the verticality of these chimneys is quite impressive. Do you expect to see growth, or are they, you know, based on the data we have, we think maybe 30 meters is the highest?
Okay, so we are sitting here looking at bathymetry generated from an AUV overflight from 2015, I believe, 10 years ago. Maybe if we had run this yesterday, it might look different. And that might include the fact that that 30-meter chimney has fallen over, right? So that's one thing I'm sort of anticipating is maybe if there have been tremors in this area, it could have destabilized some of these spires. We saw that in the Endeavour vent field where the 42 meter high Godzilla was just the most spectacular thing. And then like one year we went there and the whole, it was Godzilla's kneecap, basically. The whole chimney had fallen over in a tremor in the area. So we got an active Earth, and maybe it's grown, maybe it's fallen. We'll just find out soon, Kyle.
It's an anticipation. I'm curious what's on your mind. That's very helpful. It's good insight. That makes me wonder too about when these sites do collapse, how that affects the ecosystem of those creatures. Obviously that probably leads to more venting in different ways if there is still active.
Could be.
Yeah.
Could be. At the base of Godzilla was another little structure called Bambi.
Okay.
And that had grown when at Endeavour when Godzilla went over. So don't know.
Interesting.
It just may be that because the heat is retracting further north. Oh well, just don't know. We'll find out.
Yeah. Yeah, we had a question in the chat a little while ago about the life of these vents, and I think it's a dynamic system, so it's hard to determine a life cycle. Is there any sort of predictors between these black smokers, for lack of a better term, than the white smokers in terms of how long? Obviously, there's that big temperature differential.
Oh, so much more dynamic are the and it's not so much white smokers. It's actually the behavior of the volcanoes. And what we were seeing on the Mariana Arc, the volcanoes are much more dynamic than what we're seeing down here. So those are far more likely to be highly changeable, and we will be diving at another site, Northwest Rhoda, that we've Bill through his work has tracked over a decade, and you just see the massive changes that have happened there. We're in a back arc spreading center that is actually relatively stable. Slow spreading, not big, massive earthquakes, and for the most part, not a whole lot of eruptive activity, although there's a lava flow, fresh one to the south of us. And one of the things that we've found over the decades of exploring vents on spreading ridges is that there are some places in the world where they are very stable. The original idea was that hot vents blinked in and out just over years. When we went so Alice Springs discovered in 1987, it's been slowly cooling, but when we went there 35 years later, it was a little bit smaller, but looked very much the same with the same animals. So over
starting to get
3.5 decades, we didn't visit it this time. It really was very stable. The same thing in the Lau Basin area. There's been a very careful surveys comparing over 2.5 decades, one chimney, photographic imagery done really carefully right back to the same site, and almost nothing had changed at all, not even the tiny bit of chimney growth, same animals, highly stable. There are places we've been visiting since 1984 in the Endeavour vent field.
I would say
there's some changes in the chimney shapes, but the whole field is still doing the same.
Come on, stop on the winch.
thing.
I'll stop on the winch.
So there can
turn on
be
your
high
thrusters
stability.
and auto heading.
And so that's a little bit my hope behind what we're going to see here, is that it just has been maintaining. Voodoo site, the donut, is actually constructed of sulfides, so Bill tells me, and it was would have been a massive sulfide deposit that somehow was affected by some sort of some gas that came through. So by the size of the amount of sulfide deposited, that suggests this can be pretty old here.
Was that you, Ed?
No, should not be. What'd you get? No, that was not me.
Right.
All right, so as we approach the bottom here at Hoffaday Vent Field, we'll pass off to operations to let them get us safely to the seafloor.
Let me know if they come back, otherwise I'll poke the decoder.
Copy, I'll check in a second here.
Oh, come on, why'd you do that, man?
They're back.
They're all back?
All back.
Right. You can, if all the gauges are at 6 or above, you can make a note in the log there.
Bottom on site.
Right. Looks like there's a structure right where waypoint 2 says it should be. Okay, Mackenzie, come down 10 meters for me. ROV is now at waypoint 1. Testing, auto XY.
Yeah, sounds good.
Ready, Ed?
Ready when you are.
How are all those gauges, Mackenzie? Still nominal? Gauge check, check. Okay, Ed.
We're coming in.
I'm racked back. I don't know if you want to be racked out. I don't care.
No.
I do want to, here, give me a second. I'm going to move the camera.
Yeah, coming out.
That's small beta.
Lined up.
Yeah.
And 80% luminance. Should be about there. I'll call it good there.
You all
Focus,
good?
focus. Yeah, I'm ready to do black balance.
Roger.
All right. It's going to take the camera dark for a couple seconds. It's intentional, and it is starting now.
Oh, it's dark and scary down here. In a new neighborhood.
That looks good. We're doing a white balance starting now.
Roger.
And save that. White balance saved, good white balance coming out and brightening up. Ready to go.
Roger. Mackenzie, see that red dot out there at 80 meters? Bring our head around whichever way doesn't put a turn in my tether. Light it up right in front of you.
Ed, it's Bill behind you.
Yep.
Could I get the HYPACK survey screen on the lower screen back here?
Yeah.
You all good, Anna? All good, Mackenzie? Roger. What was our first beeswax here? A rock?
Sure.
Ooh, yeah.
So we are at waypoint 1. I'm going to start moseying into waypoint 2, looking for a rock.
I think Sarah might be working on it right now. Sorry, Anna.